For 105 years, Cummins built their entire reputation on one thing: diesel engines that outlast everything else. In all that time, they've never made a single gasoline engine for production. The shocking truth about Cummins B6.7 gas is that it should never exist. But it does exist. And what they just unleashed is making diesel engineers question their entire careers. Why would the diesel king suddenly build the one thing that could kill their own business? Let's dive in. It's 1919. Cummins starts building diesel engines and never looks back. For over 100 years, diesel was their thing. Cat, Detroit, and International all tried gas engines at different times. But Cummins? Pure diesel. Never even thought about anything else. Cummins built their name on one simple promise: diesel engines that work harder, last longer, and save money. The famous 5.9-liter in Dodge Rams, the 6.7-liter that changed pickup truck towing, the ISX that powered America's highways. All diesel, all the time. But by 2020, the diesel world was falling apart. Modern pollution controls turned simple engines into computer nightmares. DEF tanks that freeze in winter. DPF filters that clog every 100,000 miles. Regan cycles that leave drivers stuck for 45 minutes. EGR systems that fail and cost $8,000 to fix. Fleet owners started doing the math. A DEF system failure could cost $12,000. A blown DPF meant $5,000 out of your pocket. Add in downtime, towing costs, and lost money. Suddenly, diesel wasn't the money saver it used to be. California made things worse with pollution rules that basically banned older diesel engines. Other states started copying them. The writing was on the wall. Diesel's complexity was becoming its biggest weakness. Meanwhile, gas engine technology was quietly getting better. Ford's 7.3-liter Godzilla V8 was proving that gas engines could handle work truck jobs. But gas engines always lacked the low-end pulling power that made diesels perfect for heavy hauling. Into this mess steps Cummins with an announcement that shocked everyone. After 105 years of diesel-only production, they were building their first gas engine. Not just any gas engine, one that was built on their most successful diesel platform. Industry experts said it would fail. Cummins doesn't understand gas engines, they said. Diesel customers will never trust a gas engine. It's too little, too late. But Cummins wasn't just throwing a Hail Mary. They were solving the biggest problem in trucking: how to get diesel performance without diesel headaches. And the solution was hiding right in front of everyone. Here's where this story gets crazy. When Cummins showed the power charts for the B6.7 octane, mechanical engineers couldn't believe what they were seeing. A gas engine making 660 pounds of torque? That was diesel territory. Let that sink in. A gas engine running on regular 87-octane fuel, making more pulling power than most V8 diesels from just 10 years ago. But it wasn't just the peak numbers that shocked everyone. It was where that torque happened. Most gas engines need to rev to 3,000 RPM to make power. The B6.7 octane hits 500 pounds of torque at just 900 RPM. By 1,200 RPM, you're already at 550 pounds. Looking at the actual power chart tells the whole story. That solid red line showing the B6.7 octane climbs faster and stays flatter than anyone expected from a gas engine. We're talking about usable pulling power from idle all the way to 2,400 RPM before it starts dropping off. Compare that to Ford's 7.3-liter Godzilla V8. It makes an impressive 430 horsepower, but only 475 pounds of torque. The Cummins makes 185 fewer horsepower, but 185 more pounds of torque. That's the difference between a race car engine and a work truck engine. But here's what's really wild about those power numbers. In certain RPM ranges below 1100, the B6.7 octane actually outpulls Cummins' own diesel version of the same engine. Look at the charts. The gas engine's solid red line sits above the diesel's dotted line in the low-end range. A gas engine beating its diesel cousin at low RPM? That shouldn't be possible. The diesel version eventually takes over around 1100 RPM and climbs to peak torque at 1400 RPM. But for stop-and-go city driving, delivery routes, and pulling away from traffic lights, that sub-1100 RPM range is where you live. And in that range, the gas engine wins. Cummins offers the B6.7 octane in multiple setups. The top-level 300 horsepower version delivers that headline-grabbing 660 pounds of torque. But they also tested 200, 220, and 260 horsepower versions. Interestingly, every version except the 300 horsepower model makes the same 600 pounds of torque. That consistent torque output across different horsepower levels shows Cummins' focus on work truck jobs. They're not chasing peak horsepower numbers to win magazine tests. They're building for the low-end grunt that commercial operators actually use. The fuel economy numbers were equally surprising. Cummins claims 10% better efficiency than other gas engines for a medium-duty truck running 50,000 miles per year, which translates to roughly $2,000 in annual fuel savings. But here's what really caught attention: the maintenance schedules. While diesel engines need service every 10 to 15,000 miles with expensive synthetic oil and complex filter changes, the B6.7 octane keeps the 15,000-mile oil change schedule using regular gas engine oil. Think about what that means for fleet operations. You're getting diesel-level service schedules without diesel-level complexity. No special synthetic oils costing $300 per change, no complex multi-stage filter systems, just regular motor oil that any parts store stocks. The cost comparison shocked fleet managers. No more $800 annual DEF costs. No more $3,000 DPF replacements every 150,000 miles. No more $12,000 emission system failures. Just basic maintenance that any shop could handle. The reliability numbers told an even better story. While modern diesel engines average 85% uptime due to emission system problems, early B6.7 octane trucks were hitting 97% uptime. More time working, less time broken. Fleet managers started doing calculations that seemed too good to be true. Take a typical delivery operation running 10 trucks at 60,000 miles per year each. With diesel trucks, you're budgeting $8,000 per truck annually for DEF, DPF cleaning, and emission system repairs. That's $80,000 per year for the fleet. With B6.7 octane trucks, those specific costs disappear completely. You still have regular maintenance, but you get rid of the entire category of emissions system expenses. For a 10-truck fleet, that's potentially $400. It's a commercial engine from day one, designed to handle the abuse that kills lighter-duty engines. The genius is in the inline-6 setup. While competitors use V8 designs, Cummins stuck with the straight 6 layout that made their diesels legendary. Inline engines are naturally balanced, creating less vibration and internal stress. That means longer part life and smoother operation. Think about what this means in real terms. V8 engines create built-in vibration because the firing pulses aren't perfectly balanced. Over hundreds of thousands of miles, that vibration turns into early wear on engine mounts, transmission parts, and cab structures. The inline-6 gets rid of this problem entirely, but the real breakthrough happened in the cylinder head. Cummins completely redesigned the combustion chambers for gas's different burn characteristics. The compression ratio drops from diesel's 17:1 to gas's 10.5:1. Spark plugs replace injectors. The valve timing gets optimized for gas's faster flame speed. The combustion chamber design required sophisticated computer modeling to optimize flame spread. Gas burns faster than diesel, but it also has different knock characteristics. Cummins had to create chambers that promoted complete combustion while preventing detonation under load. The intercooling system also needed adaptation. Gas engines run higher exhaust gas temperatures than diesels, especially under boost. The intercooler had to be sized to handle the increased heat load while keeping compact packaging for commercial chassis integration. The fuel system simplifies dramatically compared to modern diesels. Instead of high-pressure diesel injection running at 30,000 plus psi with complex common rail systems, the B6.7 octane uses standard port fuel injection at 60 psi. Any mechanic familiar with gas engines can service it, but don't mistake simple for crude. The fuel injection system uses sophisticated computer control to optimize fuel delivery across all operating conditions. Multiple fuel maps ensure optimal combustion from idle to maximum load, while maintaining emission compliance throughout the operating range. The emission system represents the biggest advantage and the most complex engineering challenge. Diesel engines need SCR systems, DPF filters, and complex regen cycles. The B6.7 octane uses a simple three-way catalyst, the same technology that's worked reliably in cars for decades. However, scaling three-way catalyst technology for commercial duty cycles isn't simple. The catalyst must handle higher exhaust flow rates and more severe thermal cycling than passenger car applications. Cummins had to develop catalyst formulations that maintain efficiency over extended service intervals. The catalyst placement required careful engineering to ensure proper light-off characteristics while protecting against damage from road debris and thermal shock. The system includes sophisticated temperature monitoring to prevent catalyst damage during cold starts and high-load operation. Think about what that means. No DF tank to freeze, no DPF to clog, no regen cycles to interrupt your day. The catalyst works passively, cleaning exhaust gases continuously without any driver intervention or maintenance requirements beyond replacement at extremely high mileage intervals. The computer systems blend the best of both worlds. Diesel-level sophistication for power delivery, but gas-level simplicity for diagnostics and service. Standard OBD2 protocols mean any scan tool can read trouble codes, unlike the proprietary systems required for modern diesel diagnostics. The engine management system coordinates ignition timing, fuel delivery, boost control, and emission system operation thousands of times per second. But unlike diesel systems that require specialized diagnostic equipment and training, the B6.7 octane uses familiar gas engine protocols that most technicians already understand. Cummins also engineered the B6.7 octane for transmission compatibility with existing commercial applications. The engine works seamlessly with Allison 2000 and 3000 series transmissions, keeping the same mounting points and control interfaces as the diesel version. The power delivery characteristics were specifically tuned to match diesel-like torque curves for smooth transmission operation. This means fleet operators can retrofit B6.7 octane engines into existing chassis without transmission modifications or driver retraining. The cooling system received attention for commercial duty cycle requirements. Gas engines typically run higher operating temperatures than diesels, especially under sustained load. The cooling system incorporates larger capacity radiators and high-flow water pumps to maintain optimal operating temperatures during extended heavy-duty operation. But before you think this is all perfect, let's talk about what mechanics are seeing in the real world. Gas costs less than diesel in most markets, and the B6.7 octane's 10% efficiency advantage over other gas engines helps offset any difference with diesel economy. Insurance considerations favor gas engines. Some insurers offer lower rates for gas-powered commercial vehicles due to reduced fire risk and simpler systems. The savings might only be 5 to 10%, but it adds up over fleet operations. Resale values remain unknown since the engine is too new, but early indicators suggest strong interest in the used market. Buyers are specifically seeking diesel performance without diesel complexity. Driver satisfaction translates to financial benefits. The B6.7 octane's smooth operation and lack of emission interruptions improve driver retention. In today's driver shortage, equipment that attracts quality drivers has real value. For a typical 5-truck operation running 75,000 miles per truck annually, the B6.7 octane could save $15,000 to $20,000 per year compared to equivalent diesel operations. Over a 10-year period, that's $150,000 to $200,000 in operating cost reduction. The payback calculation depends on purchase price premiums, but early indications suggest the B6.7 octane will cost less than diesel equivalents due to simpler emission systems. If prices are comparable, payback happens in the first year through reduced operating costs. Smart fleet operators are calculating total cost of ownership, not just purchase price. The B6.7 octane's lower maintenance costs, eliminated DEF expenses, and reduced downtime create compelling economics for many applications. The shocking truth? Cummins didn't just build a gas engine, they solved the biggest problem in commercial trucking. After 17 years of increasingly complex diesel emission systems, they found a way back to mechanical simplicity without sacrificing performance. The B6.7 octane proves that innovation sometimes means going backward to go forward. Instead of adding more complexity to diesel engines, Cummins eliminated the complexity entirely while keeping the performance characteristics that made diesel engines essential. This engine represents more than fuel savings or maintenance reduction. It's a fundamental rethinking of what commercial vehicles need. Reliable power delivery without operational interruptions. The B6.7 octane delivers both. The industry implications extend beyond Cummins. Other manufacturers are watching closely. If gas engines can deliver diesel-like performance with gas-like simplicity, the entire medium-duty market could shift rapidly. For truckers, this technology represents choice. You're no longer locked into diesel's complexity if your application doesn't require it. The B6.7 octane opens new possibilities for operations that value simplicity over peak efficiency. The timing couldn't be better. As emission regulations tighten and diesel complexity increases, the B6.7 octane provides an alternative path forward. It meets current standards while avoiding future regulatory risks. Environmental considerations favor the gas approach. While diesel engines achieve better fuel economy, gas combustion produces fewer particulates and NOx emissions. In urban applications, this advantage could become crucial. The technology establishes a foundation for future development. Cummins' Helm platform positions this engine for alternative fuels, including natural gas and hydrogen. Today's gas engine could become tomorrow's carbon-neutral power plant. Are you ready to trust gas for commercial work? Would you trade diesel complexity for gas simplicity? Drop your thoughts in the comments below. If this video just saved you thousands in future maintenance costs or opened your eyes to a diesel alternative you didn't know existed, smash that like button and subscribe with notifications on. Thanks for watching. We'll see you in the next video, where we explore more breakthrough technologies that are quietly revolutionizing the trucking industry.